Welcome back to BayTutors Intermediate/Advanced Camp, Programming Camp, Day 3.
And as always, we're excited to have you guys here with us today, and we have a interesting material prepared for you guys.
Okay, so with that, the first thing we're going to cover today is we will be reviewing your worksheets from the class on Wednesday. So Arnav will go ahead and start reviewing the worksheets right now.
All right, so here is the worksheet from last session. And so the first question was about classes and objects, and it asked, if you create a class dog, will it have a default constructor so that you can initialize the statement dog equals new dog? And the answer to this is actually true. And what happens is whenever you create a class, but you don't have a constructor inside of that class, Java automatically creates like a default constructor that still allows you to initialize that object without having a constructor. So it does actually work. All right, so for the second question, it asks us to create a rectangle class with the following information, and I'll just go ahead and write it out right now. So I'll transfer over to Eclipse. All right, so it asks us to create a rectangle class, so I'll go ahead and create a class called rectangle. And let's look at the instructions that the problem had. So I'll also just put it in a comment up here so that we can refer to the instructions. And the first thing it asks us to do is have attributes representing the width, the height, and the color of the rectangle. So as always, make them private, private variables. So private double width, and then private double height, and then private string color, since it asks us to make the color as a string. And note that these don't have to be doubles, they can be integers, but for the sake of this question, we'll be using them as doubles. It doesn't matter if you did integer, so that's just take note. So then we'll create the first constructor, which is where we input the parameters. So public rectangle, where we input double width, double height, and string color. And then we just go ahead and initialize the three using the this keyword. So this width equals width, and then this height equals height, and this color equals color. And again, what we're doing here is we're taking this, the variable that we pass in, and setting it to this, the variable that's within the class. And we can do that with this keyword, which refers to the object's variable. So the second constructor is a default constructor, so we'll go ahead and create that. And this time we're passing in no parameters since it's the default constructor. So we initialize the width to, looks like we initialize it to 15 as the instructions specify, and then we initialize the height to 9, and then we initialize the color to red. And again, it's a string, so we surround it with quotation marks. And then third step is having a method that calculates and returns the perimeter of the rectangle. So we'll go ahead and do that. So since we're returning a value, we want to have a return type be a double. So
hey, Arnav. So Angshu has a question. He said, do you always need to write both constructors for all your classes, or can you just use one constructor?
All right, so to answer that question, no, you don't always need to have two constructors. You can actually only have one. But for the sake of the question, we required you guys to do two. So no, you don't need to have two, but it's always just better to have more variety and easier implementation of your code, I guess. So let's continue the area method. So public double get perimeter. And since we don't have any parameters, we can leave this section blank, and then we calculate the perimeter by doing simple math calculations. We return width times 2 plus height times 2, and then oops. Okay, so I'm sorry, I forgot to have a name for this. The double perimeter equals this dot width times 2, and then we return that. And with that, we finish that. And in case you wanted to shorten this down to one line, you can actually just we can actually just comment all of that out and put everything in one line. So we can just say return this, and that just basically makes it shorter and easier to read, I guess. So in case you wanted to do it with the shortcut, you can, but for explaining sake, we did it in 2 lines. So the second method was calculate area. So public double gets area. And same thing here, where we just return width times height. And then lastly, it asks us to create getter and setter methods for each of the things. So I'll only create one for time's sake, but the question asks you to create one for the width and the color. So for this one, we'll do one for the color. So public string gets color. And then we simply just return color. And then we also have public void set color. Here we just do this dot color equals to color, where we pass in a string color, and that's that. And as for, and notice how for this we actually didn't use this keyword, and that's okay. But generally, it's nicer. It's like easier to just use this keyword since that avoids confusion. And one thing to note about this keyword is that you can only use it when you're like referring to one variable. So you can't do something like this, for example. So you can't do like this dot width times height. So when you do this, it'll actually throw you an error because you're referring to, like, you can't refer, like when you're doing this, you can only refer to one thing at a time. So you can't refer to two things, but you can instead do this dot width times this dot height. So that's just a quick note about using this keyword. And with that, let's get back to the worksheet. All right, so the third question asks us to write the output of the following code, where we have a class dog, and then we have all of these attributes that are, again, private. And then let's actually just scroll down to the main method and see what they're asking us to do. And then from there, we can take a look at the class and follow along the code. So the first thing it does is it creates a new dog using the default constructor, as it has no parameters. So we create dog1 equals new dog. And if we scroll up to the default constructor, we can see it sets the age to 6, the name to Max, and the owner name to Bob, and the breed to Beagle, with the weight being 23.53. Then if we go ahead and look at the main method again, we can see that we actually do dog1.setName to Pluto, and then what that does is it overrides the current name that we stored, which is Max. So we actually override the current name, and we set it to Pluto. And then after that, it asks us to print out dog1.getInfo, and dog1.getInfo actually just returns a string that includes the name of the dog, and then so the name is obviously Pluto, and then it returns. So it actually just prints out this. So it prints out Pluto, a 6-year-old, and then Beagle was the breed, I believe, in the default constructor. So that's what it actually prints out. And with that, we can move on to the fourth question, which is asking, suppose you work at Yelp and we're tasked with finding an efficient way to store and store review objects, which are customer reviews. And then we're just supposed to write out a plan for this. So then we can simply say, so I think an efficient design for this class would be having attributes for the name of the reviewer, as well as an integer for the number of stars they gave the project. In addition to that, having getters and setters for each of them. So having getters and setters for each of them is always good to have, as they're easily accessible and you can change them at any time. And then lastly, it's probably wise to have some other methods, such as like having set review is obviously one of them, but then we can also have other attribute, like, I guess, we can have a constructor for the review itself. So having a constructor where we pass in name and review. And then that's basically just a simple design for a class. And that, let's start with today's work.
Okay, yeah, thank you, Arnav, for reviewing the worksheet. So I think with that, we're going to go ahead and start with today's lesson. So I'm going to go and share my screen. And yeah, so here we are. So let's go ahead and begin. All right, guys, so our agenda for today. So first thing we did was we reviewed our worksheet from Wednesday's session, which Arnav did, and now we're going to be going over, today's main focus is going to be on strings and like printf and APIs. So today we're going to start off with going over strings, what they are, some string query and translation methods, then moving into the printf statement, as well as going over Java APIs. So the first thing we're going to go over today is strings. So first off, what are strings? I'm pretty sure most of you are familiar with strings since we've actually used them in the previous worksheets as well as before. But just as a quick overview, strings are just objects of the string class, and they're not primitive data types. So this is something that people tend to confuse a lot, and it's that strings are actually objects of the string class. So the string is essentially an object of the string class. And essentially, strings are basically any sequence of characters that are enclosed within double quotation marks. So for example, hello world, or like my name, any sequence of characters or like any words or sentences that are enclosed within double quotation marks. Strings can also contain escape sequences, such as like \t or like \n, and the \t helps with indenting, so sort of like a tab. And the \n helps like create a new line. So essentially what this would down here, the hello world over here, with the \t hello world, it would actually tab the hello world. So if you were to print it out, it would indent it. And then the \n would actually create a new line underneath. So if you were to have \n and type more stuff down here, that more stuff would actually be on the next line. So those are just some escape sequences that you can embed within your string object. Also, the string class also supports the plus operator, which essentially allows you to concatenate, right? Concatenate is the word that basically means to join two strings together. That's a pretty important word to know. Concatenate is very often used in programming, which basically means to join two things together. So you're going to concatenate a string, which means you're going to be joining two strings together. So if you were to have a print statement or just a normal string, right, that says string hello plus like another string world, if you were to add them two together, essentially that would basically make hello world in one string. So that essentially add them two together. You can also concatenate a string with an integer or like other data types like booleans and stuff, sort of like this. So if we look down at this example, we have int x is equal to 5. We have string test is equal to I have, and then we can create another string object by saying string total is equal to test, right? Test is equal to I have plus x. So it's I have plus 5 plus string cats. So essentially, if you were to print this out, it would give you I have 5 cats. So that's sort of how you can concatenate strings in Java using the plus operator. So as I mentioned before, strings are objects of the string class. And as you've known from classes that we've gone over on Wednesday and just class in general, they have constructors, right? So you might be wondering, well, like when I initialize a string, I'm not necessarily, writing a constructor explicitly. And the truth is you actually are. So since strings are objects, right, they can be instantiated by using the new keyword, right? Similar to how an object is created. Like if we have an object of a dog class, we would say dog, my dog is equal to new dog plus your constructor and so on. So essentially strings can also be created in that format. So you can basically say string text, as you can see down here, string text is equal to new string, your constructor text. So basically you're passing text into your string constructor. And over here, even though they're not primitive types, strings are so commonly used, right, in Java that the Java syntax accommodates for string declaration syntax. Like another way you can declare a string can be that's similar to how you declare a primitive type. And if you were to follow along this path of sort of declaring them or initializing them the way you'd initialize a primitive data type, then those type of strings will be called string literals. So over here, the first example that we have on the right is like you creating a string object explicitly. So you're saying string, my string is equal to new, the new keyword, string school, right? And underneath that, there's a more casual way, right? How most people declare strings or initialize strings is just a string, my name is equal to name, right? With double quotation marks. And this is sort of how you would also initialize like an integer, right? Or like a Boolean. You'd say int x is equal to 5. So this is a more common way of how people would do it. And this is known as a string literal, whereas this is just a normal string object. And yeah, so string literals are essentially when you do not use the new keyword. And just a string object is just when you use the new keyword because you're creating a new object of the string class. Yeah, so just these are just a bunch of examples of how you would sort of declare and initialize strings going on to string constructor. So something to keep in mind is that essentially when you're declaring a string, this name is actually you can pass in as part of your constructor as the text attribute. And you can also declare it this way. So that's just an overview of how you would declare and initialize strings in Java. So moving on, we're going to be talking about string query and translation methods. So as you know, string is a class in Java, right? And as with any class, classes have methods, right? How we looked over methods on Wednesday. So the string class also has its own methods, and we'll be looking over that right now. So string querying methods are int length, right? So you have all these methods over here. Don't get confused with the int char int. This is essentially like the return type. So int length will essentially return an int. Char at will return a character. Int index of will return an int. Int index of char will return an int as well. So just these over here, right? These data types are essentially the return type of the method. So these are basically like your common methods. So on the right over here, we can sort of see how they're being implemented. So for example, the int length query method, if you were to call on a string, like, so let's say we declare a string 1 is equal to hello, and then we say int len, right? We declare like a integer variable, int len. We're going to set that equal to string1 dot length. So essentially the string, so basically how you think of this is string1 is your object to the string class. So you would essentially say string1 dot length or string1 dot char at or string1 dot index. So you would say the name of your object, which is string1, and you would say string1 dot length is equal to, you're going to set your variable here, your integer variable equal to string1 dot length. And as you know, the length of this string is HELLO exclamation mark. So that's 6, right? That's a total of 6 characters. So the int length method returns the number of characters inside the string object. One more thing to keep in mind is that with the length method, it also counts spaces. So if you have a space in your word, in your word, then that will be counted as part of a character. So then your length will increase or decrease, so on. So that's the first method in the string class. The next method we're going to look at is the character at method. If you tell it the name, it's pretty obvious what it does. So essentially what you're going to be doing is you're going to be passing in an index, a corresponding index in your string, and it's going to give you what character is at the specific index. So if you're not familiar with indexes in Java, here's how indexes work. Oh, okay, one sec. I think we have a question. Oh, okay. Angsha asked one. Say you actually want to include a backslash in your output. How would you do that? Oh, a backslash in your output? Arnav, do you know how, if you were to print something and you want to have a backslash in your output itself, you can just put a backslash normally, right?
Yeah, or another way of doing it would actually be using the ASCII value for that, like a character.
Oh, yeah.
So if you were to include it, you could typecast like the ASCII value, and then that would appear in your output.
Yeah, so you could typecast the ASCII value to like a string or to a character, and then you can add that in your print statement if you do not want to put the backslash. Yeah. Okay. So I was talking about indexes, right? So let's take a look at how indexes work in Java. So let's say I have a text like hello world, or just let's say we have the text world, and I'm just gonna put spaces just to make it a little bit more clearer. Bear with me here. I'm gonna add a bunch of spaces, but just think it's just the normal word world. Okay, so this is the word world. So how indexes work is that the index corresponds to each character. So if I were to draw, let's say, a table around here to make it a little bit more clean, they draw a table, right? And in this table, if I were to have lines to separate each character, like so, each cell is its own index in a string. So if we were to look at, for example, this in general. So we have index 1, index 0, 1, 2, 3, 4. So if we were to pair this up properly, this is how the index sort of correspond. So as you can see here, the W is at index 0, the O is at index 1, the R is at index 2, the L is at index 3, and the D is at index 4. So essentially, you're starting from index 0 all the way to the length of the string minus 1. So if we use the length method, as I talked about earlier, the length of this string world is 5, right? It has 5 words, but the maximum index is at 4. So essentially, one thing you can keep in mind is that the maximum index is the length minus 1. So if we're looking at the index of a string, it's going to go from 0 to the length of the word minus 1, which is what I specified down here. See if I can pull that up. Yeah, which is what I specified over here. So 0 to string length minus 1. So once again, if we're looking at the character at method, it returns the character at the specified index in the string. So if we look at character at hello, string1 dot character at 0, it return h, since h is at the 0th index in the string. Okay, so now hopefully that cleared up stuff if you had any questions about indexes. So now if we're looking at the index of string str method, it returns an integer. It returns the integer at which a certain string is located into your big string. So let's say you have a really big string, like hello world, or like welcome to my house or something, and you want to find out the index of the word my in the string welcome to my house. So essentially what you can do with this index of method is you can say, I want to find the index of my, right? You're going to pass in my, the string my, into this index of method inside the word welcome to my house. So if you're going to look at the example here, it says string str2 is equal to hi world, int n, right? You're storing the value of this index of into an int, is equal to string2 dot index of world. So what that does is index of world in here. So what you're doing is you're going to return the character, sorry, the index of the starting character of the word that you pass in. So the starting character of the word world is W, right? So you're going to find the first instance of W. Sorry, you're going to find the first instance of world, and you're going to return the first character of world, the index of the first character of world. So if you look in here, it's 0, 1. So h is at index 0, I is at index 1. There's a space. So the space is at index 2, and W is at index 3. So therefore it's going to return you 3, since W is the first character of world, and the index of W is at index 3. Similarly, if you want to find the index of sun, right, inside here, sun is not in the world. Sun is not in the word hi world. So therefore it's going to return you -1. So if the string is not, if the string parameter that you pass in is not actually included in the word, then it's going to return you -1, or else it's going to return you the index of the first character of the word that you pass in to this method. And the index of character method is identical to the index of string method, except it just looks for a specific character. So if you wanted to see, for example, the index of O in hi world, then it just look just for that O, the first instance of O. So it'd look for HI space WO. So that'd be 1, 0, 1, 2, which is the space, 3 is W, and 4 is O. So it would return to you 4. And suppose it was like hi, 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 and you said, find me index of I, right, in the word hi, hi, hi. Suppose it's a string that had 3 highs, then it would return you index 1 because it would just find the first instance of I in the hi, hi, hi string. And as shown with the example here, it says int n is equal to string 2 dot index of exclamation mark. So exclamation marks is something that you can use the character at method for, and then it would return you the value 8 because the exclamation mark is at index 8 and so on. So however, when you're writing this method, you don't need to explicitly say like you know, it says like character ch or string str. Just indicate what you're looking for by using single quotes for character and double quotes for string, and and then it'll automatically know what you're searching for. So you don't need to specify it's a character or it's a string. Just put double quotes or put single quotes, and that will basically indicate what the method is supposed to be looking for. So and if you have any questions about these query methods, the length, the character at, index of, please type in the chat if you guys do have any questions right now. Okay, so hopefully that made good sense to you. So now we'll be talking about some string translation methods. So the first translation method is the toLowercase method. And this returns a string in lowercase format with the same characters as the original string object. And if we were to look at the example, right, string greeting, we make a string object here, sorry, a string literal here. String greeting is equal to hi world, and it says greeting is equal to greeting.toLowercase. So we're basically setting greeting2.lowercase, and this would return the lowercase version of hi world. And when you say what greeting is, it'll say greeting is equal to hi world all lowercase. But notice how the string has to be assigned to the lowercase value through an initialization statement. So we can't just say like, so let's say, so we actually can't say this. We can't just not say this here. If we just say this and we just say greeting, and we just say this line, greeting.toLowercase, that won't modify this greeting value. It will not modify that object. It will return, right, a lowercase version of the greeting object. It'll return a new string object that's a lowercase version of greeting, but you're not storing that new object in anything, right? You're just returning it, but it's not getting stored anywhere. So if you were to just do this and print out greeting, it would just print out hi world with capital. It will not actually make it lowercase. So this is something called, and this is because strings are immutable in Java, and I'll be going over immutability in the next slide. So you actually have to explicitly set a value of another string equal to the greeting to the string.toLowercase. So the .toLowercase will return a new string object that has the same characters as the original string object, but it's just lowercase. So it'll return a new object. It will not modify the same object. Hopefully that made some sense. And similarly, the toUppercase method will return a string in the uppercase format. So same thing, make sure that you do store that in another object as well. The trim method will essentially remove the white spaces or the spaces between in the front of the string and at the end of the string. So in the leading and trailing white spaces, so it'll remove the leading and trailing white spaces. So if you have, for example, here, trim me, as you see, there's a space here, there's a space here. So when you do trim, then it'll just remove those spaces and just return you the same string with just the spaces removed. And once again, remember, you have to set that to another string object. The next one is called the substring. This is a very commonly used translation method. The substring is essentially, what you do is it'll return a substring, right? It'll return a substring of the string object from the beginning index to the end of the string. So if you don't specify an end index, it will just go from the beginning of the string all the way to the end, and it'll return you that specific part. So for example, if we say string sample is equal to hamburger, sample is equal to sample.substring 3, then what it'll do is sample will now be equal to burger. So what it's doing is if we look at this hamburger string over here, it starts at index 3, right? He specifies index 3. So index 3 is 0, 1, 2, 3. So index 3 is at the letter B. So what it'll do now, it'll just cut off here and it'll just return you this. It'll not return you this. I'll just return you the box portion. I'll just return you from 3 onwards. whatever there is from onwards. And yeah, so if you don't specify an end index, it'll just go from the beginning to the end if you don't specify an end index. So that's what a substring is. But there's another format. You can specify the end index. So if you were to specify the end index, then it'll return you, like for example, if you say index 4 to 8, right? That is from 0, 1, 2, 3, 4 as the letter U, and 8 is 6, 7, 8. So 8 is E. I'm sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is R. So what this does is it'll return you the substring between the indexes 4 and 8, but it will not include the character at the 8th index. So the end index is not included, right? It does not include the ending character. So I think what it will actually give you is, technically it'll give you the index from 4 to 7. It will include index from 4 to 7, but it will not include the index. It will not include the character at index 8. So that's why if you see here, even though R is the 8th index character, it does not include R. It only goes up to the index 7. So the beginning index is always included. The ending index is not included. So that's something that you should keep in mind with the substring method. Yeah, so that was some simple translation methods that are very commonly used in Java. So once again, if you have questions, please feel free to voice them out right now in the chat. Okay, so then I guess we'll move on. So I mentioned something about strings being immutable in Java. So we'll go and talk about that right now. So string immutability, or the immutability of strings in Java, means that once you create a string object, you cannot modify that same object. Instead, you can use methods like substring or toLowercase or all the methods I talked about earlier to return a new modified version of the string, but the original string will not be modified. So let's say you have a string x equal to name, and you say name.toUppercase, right? You make the name all uppercase, it'll return another string. It will not change the original string to uppercase. So if you were to take a look at this here, here's what I'll show you. So if we look at this one, right, the string welcome is equal to hello world, and we say welcome.toLowercase, welcome.toLowercase will return, essentially, it'll return hello world. It'll return that, but where are you storing it, right? It returns a new string called hello world, but it's not being stored anywhere, right? You're just calling it, but it's not being stored anywhere. And that's why if you print out, right after that, if you print out welcome, right, the original thing, if you just print out welcome, then it will return hello world. It will not actually make it lowercase. So as you can see, unless you store it into another variable and you just print out, unless you store it into another variable, the welcome thing will not be changed. So welcome will never be modified. So yeah, that's what immutability is that the original string will now be modified. However, it will return a new string that is the modified string of the original one. So as you can see down here in the second example, here we're setting the welcome value equal to welcome.toLowercase. But you might be wondering, right? You just said strings can be modified, but what I'm doing here, I'm not modifying by setting welcome equal to welcome.toLowercase. Welcome.toLowercase returns a new string that is hello world all to lowercase, and I'm storing that new string into the same welcome string object, except now I'm reinitializing the welcome string object. So now the welcome string object will now be the welcome.toLowercase. So now when you print it out, it'll be hello world. But you can do something else. You can also create another string object and set like maybe a string object called like goodbye or something. You can create another string object and set that equal to this. But the main idea that I'm just trying to get out here is that strings are immutable. It basically means that if you were to use a string method on your original string, it'll return a new version, a new object of the string, but it will not modify the original version. If you'd like to modify the original version, then you'll have to reinitialize it to the modified version of the string. You have to reinitialize the original object to the modified version of the string. So hopefully that wasn't too confusing. It is a little bit confusing at first, but hopefully that made some sense to you. So once again, please feel free to voice out questions right now if you do have any. Okay, so now, yeah, so that's a lot of stuff on strings, but we're not done quite yet. The last thing on strings for today is going to be string comparisons. So the first comparison method, if you want to compare like a string to another string to see if they're equal or something, then you would use the equals method, which essentially is a Boolean that will evaluate the contents of two strings to determine if they're equal or not. It's pretty self-explanatory. So if you say, look at the example, string a name is equal to Matt, string another name is equal to Matt. If a name dot equals another name, print out the same. And since it will compare these two, so you say a name dot equals. So you say your first name, right? So the first thing that's there, or it's called the callable object. So use your calling object, so which is like a name. You say dot equal to another name, so it'll compare a name and another name and see if they're equal. If they are equal, then it'll execute your thing. So that's essentially how the equals work, equals thing work. The equals ignore case is basically the same thing, except it'll ignore the case. So if you have, for example, if you say Matt, and you see capital MAT, it'll still consider that they are equal with each other because you're ignoring the uppercase or the lowercase. Yeah, so they both return Boolean, so they'll return true or false. And you can compare. You can use this method. You can compare a string with a string literal, a string with a string object, or a string with just like a normal string. Like you don't have to create an object for it. You can just say just normal string, like how we did over here with the capital MAT. So that's with the equals and equals ignore case method. They're pretty self-explanatory. You just say this string dot equals this if you want to compare whether two strings equal each other or not. One common misconception is that the equal operator will actually help you compare the two strings together, and that's actually wrong because the equal operator will actually compare the reference values, right, or the address of where the object is stored in memory, and not actually the data members of the content. So as you know, when you create like an object or something stored in your memory in a certain address, right, it points to a certain address in your memory. And since strings are not primitive types, right, they cannot be compared with the equal operator, and that's why they have their own equals operator. And when two string literals, right, are initialized with the new keyword, sorry, without the new keyword, if there's string literals, and they have the same content, then they will basically point to the same address in memory. So if you were to use the equal there, it will point to the same address in memory. So if you have string a name Matt and string another name Matt, you see them two over here, they actually both point to the same address in memory, which is what will happen if you have string literals with the same content. So just the rule of thumb is that just do not use the equal when comparing strings. Just use the dot equals method or dot equals ignore case method when you're comparing strings. Okay, so that was our lesson on strings for today. And now Arnav will be talking about the printf statements.
Yeah, right. So as you guys probably already know by now, you can use system.out.print or system.out.println for printing, and these are generally quite easy to use. However, there is a third printing tool called printf, and what that allows us to do is format text much easier and is generally a lot more convenient when you use it right. So unlike regular printing like system.out.print, printf takes in multiple parameters, and the first argument contains text and special formatting tags, which we'll talk about in a bit. And then the following parameters are the actual like content of those tags. So in the table below, we can see a few formatting tags where the first tag is percent, like as a rule of thumb, whenever you have a formatting tag, you always have a percentage sign in front of it. So that way, like the compiler kind of knows like, hey, we want to print F here. So then you always have to have a percentage sign before your tag. So the first tag is %s, which is for strings. So then if we look at the example, if we do printf of like s with that tag and then hello world, it prints hello world. And again, it would actually be system.out.printf and not just printf, but for the sake of keeping it short, we just did printf. The second tag is percentage sign and then lowercase d, which is for integers. So if we do printf, John is percentage sign d years old, and then the next parameter is 5, which is an integer, we actually print out John is 5 years old, because over here Java kind of like ignores the fact that we need to print the percent, like it treats the percentage sign d as like a thing for printf as a parameter, so then it actually prints that out instead of the plain text. And then the last thing we have is for doubles, which is f. The tag for that is f. And then if we just do printf like f f is pi, and then we insert 3.141 as a parameter, it prints out 3.141 is pi.
Yeah, so as Arnav mentioned, these are just some super simple ways of how you can implement printf. And obviously you could like not use printf for the first two or first three. But these are some simple examples, but in certain situations, printf is actually much more efficient for you to use if you want to print other data types using the printf statement. But these are just some pretty basic examples of how you can use a printf statement for formatting in Java.
All right, and then on the next slide. So on this slide, we have some more detail for printf. And then in the previous slide, we just looked at the formatting tags, but this slide kind of goes more in depth with that. So the format for printf is we have the percentage sign, and then a flag, and the width, and the precision, and then finally the tag, which is like S, D, or F. And then let's look at each of those parameters in more detail. So flags are basically like where you can add special characters in front of the printf. So that's like you basically like a $sign or a plus, you can add that in front of the percentage sign, and then that would be included in your printf statement. And the second thing is width, which is the minimum number of characters you want to print out. And what that basically does is it adds the additional white space that you don't already have at the end of your like statement. And then if you add a minus sign in front of the width, actually it makes it left aligned. So then it adds white space in front of your parameter instead of after it. And one thing to note about width is that if you have like a width like 5 and then your word is like a 2-letter word, it actually only prints out 3 like white spaces instead of 5. So it prints out how many ever white spaces it needs to get to that number that you specify. The third tag is precision, which is how much you want to round decimal place to. So for example, if we had 0.2 as our precision thing, then it would round to 2 decimal places, and that's pretty simple. And then the last thing is tags, which we went over previously. So here are just some examples of printf. In the first example, we do system.out.printf. And then in quotations, we have cookie, and then we do percentage sign to f. And then as a parameter, we have 4.984. And then when we actually run the code and print it, it prints out cookie and then 4.98. And it prints out only 2 decimal places since we specified that with the 0.2f tag. The second example we have, we print out this thing with the, negative 10s and the $sign and then 10.2f. So the first thing is actually just a string where we have a minimum of 10 characters. So it prints out that. And the second thing is a decimal where it prints out, where again, the width is 10. And then we print out, when then we round to 2 decimal places. So if we look at the output, it prints out chips and then has the white space. And then it prints out the $sign as we specified before the percentage sign. And then it prints out the number 10.25, which we specify with the 0.2f tag. And that's it for printf. Now we can take a look at APIs. So Nanda, if you want to give me screen sharing permission now.
Yeah, one sec. Okay, I think you have permission now.
Yeah. All right, so an API in Java essentially describes everything you need to know about a certain class, and you'll refer to these very often when coding, and you can use them for things like strings, arrays, and it's like much more. But for now, we'll be only taking a look at the string example. And you can just simply access APIs by searching them up online. Like you can just Google like Java string API and it'll come up. And an API contains the following info. It contains description of the attributes or like the variables of a class. It also contains descriptions of the constructors and the parameters they take. And finally, it contains a description of each method in the class and parameters that they have and return and like values that they return. So for each description in the API, there's actually a summary and there's a more detailed version. And often if you don't know the method or you've never used it before, it's probably like better to look at the detailed version, but at a quick glance, the summary is quite helpful. So now let's take a look at the string API. So if I just, oops, okay, sorry. So if I pull that one screen share, so here's the string API for Java. So previously we did talk about strings, and now we can actually see them in the API. So at the start of the API, we have like a bunch of details about the class. It's basically just like a paragraph of details, and it explains everything about the, like, basically just a summary of the class and what it does. And then if we scroll down, we actually have a field summary, and this is actually an attribute that the string class has. So it's a static variable called case sensitive order, which is basically just a variable, and here's the description for it. So that's the only attribute that the string class has. And then we move on to the constructor summary, which summarizes all of the constructors within the class. So then this is basically just like a quick summary. It doesn't go into detail, but it basically like contains all the constructors and like the parameters that they have, as well as a short description. And the same goes with the method summary, where it has the like modifier, and then it has the actual method signature with the parameter included. And then finally, it has a short description. So if we actually scroll it down, we can go into the more detailed versions of these. So we have a like section called constructor detail, which has more detail for each of the constructors. And it basically explains everything in more detail. So like for this constructor where we have it initializes a new string object, and then it contains the parameter. So that's for the constructor. And if we scroll down some more, we have method details. So for example, we have the .length method, which basically returns the length of the string. And then here it contains the signature for the method. So it has public int, which is the return type, and the name of the method. And again, it just explains more detail. It explains the method in more detail. And the same goes with the attributes, but that's pretty much it for APIs. They're just really helpful tools for whenever you're like whenever you're working with a class.
Yeah, so like Arnav said, like APIs are extremely, extremely important. I believe that if you want to learn about like maybe the string class or just other classes in general that you'll be using when you're programming in general, I highly, highly recommend that you guys go ahead and look at their APIs because they can really just like help you get an in-depth knowledge of that class in general and just know about what each method can do and the various constructors that the class offers. And today I just covered very, very, very minimal amount of string methods. There's a bunch more out there. So if you'd like to go ahead and learn about all the string methods that just make programming a lot more easier, you can go ahead and check those out by looking at like maybe Java String API. It'll usually take you to like an Oracle Docs website, and on there you can go ahead and see all the APIs. So I highly recommend that you guys check out APIs. Yeah.
All right, and then the final thing we have for today is we're going to be introducing CodingBat. And CodingBat is basically just a website we'll use for practice problems, and has a variety of problems that cover different topics, and they often like range in difficulty. So now we'll do a walkthrough, like a demo of how you can sign up for CodingBat, and then how you can like share it with us. So
yeah, so this is actually going to be your lab or sort of like your homework for the weekend. And Arnav will now go ahead and show you how to sort of use CodingBat and all of that.
all right, so if you go to codingbat.com/Java, it takes you to this website, and it basically contains like, it's basically the homepage for CodingBat. And the first thing you want to do is create an account which you can do in the top right. And then once you do create an account, you can go ahead and click the Preferences tab at the top right of the screen, which is this tab right here. And when you click Preferences, you want to go ahead and scroll down to the Teacher Share option. And within this field, you can type in our email, which is BayTutor, which you can see on the slide. So it's this email. If you just want to copy paste it into the field over here, you can do so. So that's our email. And then once you do that, you want to click Share. And then that way we can have like, we can see what problems you've done, and then we can like grade them based on that. And then for this week, I believe we assigned 3 sets of problems. We assigned 9 problems in total. So we assigned them from warm-up 1, string 1, and logic 1. And you can go ahead and do those before the next session.
Yeah, so Arnav will now give you a quick walkthrough of how to do the first problem from warm-up 1. So I don't know if you can go to warm up 1
Oh yeah, so here's a quick
or string 1,
example of a
either one. Yeah.
problem. So if we go ahead and look at the problem, we can basically the problem when it gives you instructions at the very top, and then you can go ahead and just simply do the problem. So this problem is asking us, given a string name like Bob, return a greeting with a hello in front of it, and then finally an exclamation mark after. So the first thing you want to do is we'll solve the problem. So we'll do string final equal, or you can actually use final, and we'll talk about that later. But let's call it string temp equals to hello plus with a space plus name plus exclamation mark, and then we finally just return that type. And if we go ahead and hit go, it basically shows that it gives us feedback on the problem and what we've gotten right and what we've gotten wrong, and it basically just gives you feedback, which is pretty helpful to have.
Yeah. So Arnav, can you go back to the home screen real quick?
Yeah. So if we go back.
All right. So for today's for this weekend's homework, if Arnav, you can click on warm up 1. Your homework will be to do the first 3, which are sleep in, monkey trouble, and sum double. Those are the first 3 from warm up 1, and then I don't know if you can go back.
And then we have some from string 1.
We're gonna go ahead and do hello name, make ABBA, and make tags. And if you want to do so, you can also do the make out word. And then from the logic 1, you'll be doing the first 3. And logic is just Boolean algebra, like the thing that we talked on the first day. So yeah, so
Yes.
that's your homework for this weekend, sort of like your lab for this week that you all can work on.
Yeah, so all of this covers it's kind of a review of everything we've done this week, so you should be able to do all of that.
And also in your free time, feel free to just go to Coding Bat and just do exercises, because they're really small. They're it's pretty short method writing, and they really help build up your skill in Java and computing skills in general.
Yeah.
So that's it for day 3 of intermediate programming with Java from BayTutors. And if you guys do have any questions, please feel free to stay back, and we'll be happy to answer them. So once again, thank you guys so much for joining us for today's session. We look forward to seeing you on day 4.